Number 10. Rectangle WXYZ above will be dilated with the origin as the center of the dilation. So the origin is the center of the dilation. That basically means that this is the center of the dilation. And what that means is all you do is take the ordered pairs or your coordinate points and multiply them by whatever the scale factor is to find your new shape or to find your new polygon. And the scale factor is 2. So that means we're going from something this size to something twice as big. We're going to multiply all the points times 2. What will be the coordinates of the vertices of the dilated image? Well, we already know what the coordinate points here are. We can plot those. And then all we have to do to find out what the new coordinate points are is multiply everything by the scale factor, which is 2. Okay? So let's start with W, X, Y, and Z. W is -2, 2, -2, 2. X is 0, -4, 0, -4 in an ordered pair. Y is 4, -2, so we have 4, -2. 4 on the x-axis, -2 on the y. And finally Z, we have 2, +4, or 2, 4. Well, luckily for us, all we have to do to figure this out is multiply everything by 2 if our scale factor is 2. So that's going to leave us with -4, 4, 0, -8, 8, -4. 2 times 2 is 4. 4 times 2 is 8. And if we plot this, we can show you exactly how to look. And it should be somewhere around here. Let's go ahead and do that just to take a look. -4, 4, right there. 0, -8, so we have one right there. That'll be the x prime, or x prime. This will be w prime. 8, -4, which will be right here. This will be y prime. And then 4, 8, which will be right here. And this will be z prime. And as you can see, we have a new shape, a dilation. Sometimes they overlap. Sometimes if your scale factor is big enough, this guy will move way up here to the top part. Okay. Now, let's take a look at number 11. Rectangle WXY above, or WXYZ, will be dilated with the origin at the center again. So anytime you see origin as the center, that means all you have to do is multiply by the scale factor 1/2. What will be the coordinates of the vertices of the dilated image? So now we're making this smaller. Well, now all we have to do, and let's get rid of these, now all we have to do is multiply these by 1/2. So everything's multiplied by 1/2, so we have now a -1, 1 for W prime, X prime, Y prime, and Z prime. Here, let's go ahead. This is going to be 0 times 1/2 is still 0. This is going to be a -2. Y is going to be 2, -1. And Z, or Z prime, is going to be 1, 2. And again, I'll just show you. I'm not asking you to do this in this problem, but we can plot this. And again, remember, the key is the origin as the center of the dilation. All right, well, let's go. -1, 1. 0, -2, which is right there. Go ahead and connect that guy. 2, -1, right there. And then 1, 2, right there. And you can keep going. If you keep going by, let's say 3, it'd probably look something like this. 4, and so on. Remember, this is at the origin, so you just have to multiply everything by whatever the scale factor is. In a minute, we're going to do those where the origin is actually one of the points, and it'll expand on itself, and I'll show you that in just a second. Number 12. triangle RST below was dilated to form R prime, S prime, T prime. So we went from this guy right here without the apostrophes on it up to here with the apostrophes on it. This is R prime, S prime, T prime. So we went from here to here. The center of the dilation was the origin. So again, all we did was just multiply those coordinate points by a specific number, and that was the scale factor. Well, here it's asking us, what is the scale factor? Well, guys, all we have to do in this case is we just have to find how one point R relates to R prime, or S relates to S prime, or T relates to T prime. That's all we have to do to find out what the scale factor is. In other words, we have to look at the ordered pair, the original ordered pair, look at the new ordered pair, and figure out how you got from one to the other, just like we did when we were doing the shapes. How do we get from 4 to 8? Well, we multiplied by 2. Same thing here. So let's just plot, and we only have to do one of these. So let's just take a look at R. Ordered pair for R is -2, 1. For R prime, R prime is going to be -6, -6, 3. And guys, all you have to do is just look at one of these. Okay? How did I get from 1 to 3? What do I multiply 1 by to get through what's obvious is 3? And you can take a look at here too. Remember, we're going from the original to the new here. How did I get from -2 to -6? Well, again, I multiplied by 3, so my scale factor is 3. So if I had something that was 4, 1, and then I went to a 16 and a 4, my scale factor, I would go from 4 to 16. How do I get there? Well, I'll multiply by 4. Now, sometimes you might go from here to here. You may go from a larger one to a smaller one. In that case, you're going to have a scale factor that's less than 1. In other words, it's going to be a fraction. And all you do then is you would, if we were going from here to here, we would say, well, how do I get from -6 to -2? And it would be 1/3. How do we get from 3 to 1? That'd be 1/3 too. That'd be your scale factor. Triangle PQR below will be dilated using a scale factor of 2/3 to form P prime, Q prime, R prime. 2/3. That means we're going from a whatever shape, we're multiplying it by 2/3, which means we're going to make it smaller. Anytime we multiply by a fraction, we make that thing smaller. We contract it. If the origin is the center of the dilation, so again, all we're doing is multiples of those coordinate points, what will be the coordinates of the vertices of P, Q, and R? Well, in order to do that, we have to take a look at P, Q, and R to find out what P prime, Q prime, and R prime will be. Well, P in this case is -6, 3. So we got -6 and 3. Q is 0, 6. R is 6, 6. Well, guys, now all we need to do is multiply everything in here by a 2/3 factor to get our new coordinate points. So P prime, 2/3 times -6 is -4. You'll have to do the math on your own. 2/3 times 3 is 2. 0 times 2/3 is still 0. 6 times 2/3 is again 4. 6 times 2/3 again is 4. And 6 times 2/3 again is 4. And guys, I'm going to go ahead, I'm not asking you to do this, but I'm going to go ahead and plot these points for you just so you can see what I'm talking about. Our new P prime is -4, 2, 0, 4, 4, and 4. And we have the same shape. And a lot of these dilations, they look like they've been shrunk and slid sometimes. Okay. Now, this is a tricky one. Dilate triangle ABC by a scale factor of 3, so we're going to be multiplying by 3, with the center of the dilation at point B. Now, this is not the center of the the center of the dilation being the origin. That is different. Okay, this is with it being at B. So all you're going to have now is B is going to stay exactly where it is because that is the dilation point. Okay, now all you're doing is taking a look at the lengths of here and multiplying that by 3. We have 1, 2, 3, 4, 5. That means we're going to multiply 5 times 3. And so A is going to be 1, 2, or sorry, this is 15. So A is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? And you can draw yourself a line. And you can go ahead and draw yourself a fairly straight line here. The distance between B and C is 1, 2, 3. Sorry, 1, 2, 3. So here I'm going to go 1, 2, 3. And the same factor will be at hand here. And I'll have to show you this in class because it's kind of it's more of a difficult thing to understand. But you're basically going to have a shape coming off of this that looks like so. Whereas before we had maybe a shape like this and we dilated it about the face of the origin and we had something like this. This one, you're going to have several fairly common sides here. Okay, so again, the scale factor here is going to be 3. You got 1, 2, 3. 3 times 3 equals 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Okay, so you're basically making something bigger. You're just kind of taking it and expanding it this way. Okay, and it's asking you what will be the coordinate points of point A or A prime. Well, this is going to be negative 6, 7. Negative 6, 7. And finally, number 15, triangle KLM below will be dilated with the origin as the center of the dilation. Scale factor of 2, so we just need to multiply everything by 2. Let's go ahead and take a look at K, L, M, K prime, L prime, M prime. What was the original K? Negative 4, 3, negative 3, negative 2, negative 3, negative 2, 1, negative 2, 1, negative 2. Scale factor of 2, that means I multiply everything by 2 when this origin is the center of the dilation. So now all I have to do is multiply everything by 2. We have negative 8, 6, negative 6, negative 4, because negative times a positive is still a negative. Here we have 2, negative 4. And those are our points. And we could plot those. I'm running out of time here, but I could plot those, and so those are the points.